Yo, 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 what's up, what's up? And let's see what cool stuff we will manage to implement today. But first and foremost, we're gonna have to fix the last issue concerning... It's this one, right? Yes, the minimum height. We don't seem to be getting any minimum height. We get maximum height. We get direction. We get velocity strength. But minimum height, for some reason, doesn't really... It doesn't really do it. So let's take a look. At first, I thought the problem was activity dynamic output shader. So it's pretty much this pass we do when we render the minimum height. We do cull off and could it be... Now we do cull off and then we just return 0.5 here. But we do blend operation minimum. We fill this one up. Initially we fill it up with we had a clear color here that is... Good morning, Calvino. How's the new house? We fill it up with 1000, which should clear with color. Set render target, clear render target with clear color. Yeah. Then we generate secondary data as well. And that's just generating the MIPS if we use them, that is. And then we execute the command buffer. So the color should be 1 here. I wonder about this. We should be seeing some... colorization here. Unless the debug shader is wrong, but we'll see. And we finally settled that everything is going smooth. Nice. Nice to hear. Currently renovating our son's room because it had a lime green plastic mat as flooring and that looked horrible. It doesn't sound very good. Or it doesn't sound very pretty. Let's take a look at the terrain debug shader. Like, is this the new one or is this the old? I'm pretty sure this is the new one. Yeah. Activity height min, get UV, calculate grid, get terrain activity data, and then we do data height boundary X here. Lerp, lerp, lerp. We lerp between that value and the grid. That is a-okay. I want to double check get terrain activity data, 1 sec. Get terrain activity data. Yeah, we do it with the clamp. Sampler level is 0. This rescaling, that should be okay. Everything else works, so this should be okay. Height boundary is data in the red channel. Train dynamic output. Let's try this real quick. Return float for 0, 0, 0, 0. Should only be the red channel, but we'll double check. I sent a pic on Discord. We'll check it out. I mean, it's not the best, but I definitely understand getting rid of it. 100%. Okay, so this works. That's interesting. Oh, I might actually know what's going on here. I might know. Oh, but this is beautiful. This is beautiful. I want to see what happens with this one if we do. Okay. Okay, but we know that it renders at least. What I'm worried about is this one. Input position VS, inverse slurp 0, 1 between terrain bounds Y and input position 0 and terrain bounds Y. Is this one? Are we sending the wrong value here? I mean, sure, with the furniture and the carpet, it got blocked a bit. Yeah, that's definitely true. When a room is empty, it's much easier to spot the everything that is wrong with the room, right? Furnitures most of the time makes things much better. Yeah. Good morning, Harukanan. Okay, so the assumption I make here is that this line screws it up somehow. Probably this one being too small, which means that this one, like we always get 1 here. That is most likely the reason. But terrain bounds, if I remember correctly, I think we set this one to the correct value, but as of now, that's pretty much the only terrain bounds. This one, right? Terrain bounds. So let's take a double check this one. Base mesh bounds size. Yup. Base mesh. Why would I set base mesh here? That's definitely wrong. What we want to set is terrain bounds size. Why the fuck would I do this. Yeah, that's not good. But I'm also a little bit worried here, I think. Let's set terrain bounds dot size, I reckon. We're taking a little bit of a shortcut here as well, because we pretty much don't want to inverse lerp between 0 and terrain bounds y. So this is 0 and max height of the terrain, or it's not actually the max height of the terrain. I think it's the max height of the playable area related to the terrain. But currently we spawn the terrain at 0, 0, 0, and I think 0 is the smallest height. But that could change. Like if we move the terrain around, if we don't spawn it at 0, 0, 0, this will probably be wrong. But if we set it to terrain bounds size, we send down a float 3 to the shader that is 110, 100. Is 10 okay? 10 is probably okay. And now when I see it, this is probably not the playable area. It's actually the max height of the terrain. Or am I fucking up? Dimension is probably what we want to put in. Terrain bounds is the playable area. We have yep. I don't think it matters that much, but just to make sure we're not going to send in terrain bound size here, we're going to set in or send in dimension. And that should be the correct. I'm wondering why I'm getting this much time spent on compiling the scripts. I really need to get my namespaces in order, I think. This should be the correct. We're still getting one here. So 0 and 10. Input position vs. Did I screw up with my projection matrix? Maybe I did. And then take the minimum. Yo, what's up, the gaming zombie? Hey man, glad to catch one of your streams again. Appreciate it. What are you working on right now? We're doing trying to get these activity textures to work. Do we actually set this one? Generate set vector. Yes, we do. Do we copy this one or screw it up somewhere? Draw renderers. No. So I'm just trying to record entity movement on the terrain. So currently we store the maximum height of whatever is traversing the terrain. We store the direction of the entity traversing the terrain, and we store the strength, so by pretty much speed. But we're having a little bit of a problem with the minimum height, this one right here. Can't really seem to get it to work, which I find strange. So like, maybe our view, it's probably not view, object to world, but we should get that one for free, I reckon. But like, our character is currently at 0.5.84. So when we render to the texture, we should have inverse lerp between 0 and 10. So we should get a value of like 0.6 or something like that, 0.58, which should be smaller than 1. So our blend operation should output a smaller value here. But for some reason it doesn't. It's strange. And actually, I don't think we get... Let's try this one as well. Do we get a smaller... Yeah, we do. But definitely goes to 1 way too quickly here. Which tells me we're doing some weird stuff with sRGB, or now I'm actually starting to think that terrain debug, terrain activity data, height boundary X, terrain activity data value multiplier. Yes. Yes. We take into account, or we change it to be an actual value here. So not normalized. It's actually between 0 and 1 when we return it from here. I'm pretty sure. Terrain activity data value multiplier. Debug material, I don't think we do. Here we do. Mesh dimension, mesh resolution, mesh subquad diagonal. Okay, so the thing that is here to help us, the debugger, that one might actually be the cause of this one. We changed this one a bit. Temp. Bounce. Yeah. Where the fuck do we set this one then? Oh. I tried to be smart here, I think. Set debug mode, debug material, and then we have set material, copy properties from material, then we have set material properties, and here we set size, use scale, value range, property name, value multiplier, 10. This we definitely want to fix. But that means that this one should be 10. So we multiply this one with 10. We multiply this one with 10. And then when we output it, we do data height divided by whatever this one is set to. But height min and height max, we just take height boundary x and divide it, and return it. So what we need to do here is yeah. Did find some other various bugs when we tried to fix this, which is good, I suppose. There we go. And then this one should be more correct as well. So the higher up we go, the brighter it is. Okay, nice. Nice, nice, nice. I think that was the last thing we needed to do for finalizing the terrain rework this time around. I'm sure we will revisit this one soon. Okay, now I just want to double check so we have the snow working still, and we're probably gonna have to make some small changes to it, but I'm looking forward to double checking how the snow or weather in general works with this new system. This time around we don't need to create any new meshes or anything like that, we just reuse meshes. But we offset them a little bit differently. I don't remember. We don't have fog just yet, do we? I just want to double check the fog again, so we get proper fog on our stuff. We should be seeing some fog related stuff over here. Yeah, I don't care about that. Actually, we do have fog. It's just that... Okay, so I should be able to check it by environment density. Okay, beautiful. We don't really use it as fog. I don't know if fog is the correct term for this, but it's more used as atmospheric scattering effect. I think it looks good. Okay, so what I'm gonna do now before we move on to the snow is I'm gonna resolve a whole bunch of issues and make an extremely big commit. So this might take some work or some time, but let's double check this. I'm really gonna try and start committing more often this time around. The last couple of months have been not so good. In that regard. The main issue I want to resolve here is terrain related. And we're actually going to resolve this one. The first... Yeah, we're probably... I'm going to go through this one and move some of these things to separate issues. It's way too big currently. But let's see here. We're gonna wait a sec with the... fuck. We're gonna add action interactions. So the actions, the changes here are related to Terraform. Scripts action. Oh, this is gonna feel so nice. Then we have interactables. We have interactable inspect and action type. We added Terraform here. I'm just wondering... Let me double check this one. Environment, terrain, use, Terraform. Okay, that's how we did it. That's good. Attributes, what have we changed here? What? Is this the only change? Okay, might as well add this one as well. And then we have character body definition. This is related to something else. I think this is... Yeah, we removed information display from that. We're gonna wait with that one a sec. Before I add the full environment stuff here, generate dispose, weather, we're gonna wait with weather as well. But terrain here, what do we have? Terrain data containers. And these pretty much, they are the foundation of what we have changed. Terrain data type, added some methods and stuff like that. Terrain base, a lot of changes. Terrain fluid solver we can wait with, or I've disabled a lot of stuff here. Yes, we're gonna add this one as well. Terrain material we added, that's good. Terrain patch. Terrain patch mesh and terrain patch mesh data, they belong to the old system, I'm pretty sure. Let's take a look. Yeah, it's only used in here. And only in terrain patch mesh. So what I'm gonna do is we're gonna delete these. Terrain patch and terrain patch mesh. No, not terrain patch, what the fuck. Terrain patch mesh and terrain patch mesh data. Beautiful. The end goal is also to remove terrain patch point, but currently this one is used quite frequently in the terrain fluid solver, so we're gonna wait with that. Terrain subset. We don't use. That's also... I think we have taken what actually matters in terrain patch subset, or yeah, terrain subset, and just added it or reduced it down to one short method in terrain base. Okay, so all of this I'm okay with. Weather we're gonna wait with, but terraform, yeah, here we have done a lot of stuff. We removed like 4 classes, I think. And we have a terraform brush and terraform brush visualizer. These are probably properly split this time around, which means that terraform brush can be used by an entity that is not playable. Terraform brush visualizer, that's just for the player. But so our creatures will be able to use terraform brushes. That's great. Environment controller, yeah, we went through this. Input highlight, we're not going to include that one. Rendering renderer features, we're going to wait with this one as well. Tools, wait with that. Let's add environment, terraform, and terrain. Environment controller I want to add. and terraform. I want to add and terrain. Okay, beautiful. Okay. Let's go down. Tools, we wait with settings. We wait with shaders, environment shaders. I think we're going to add most of these. I would like to maybe delete some of this. Terrain tessellation test. So this one we utilized quite a lot when we were developing the tessellation stuff. But this time around we have terrain template here. That's what we're going to rely on. So let's delete this one. Environment shaders, terrain tessellation test. I also want to delete. Eventually we're going to have we have procedural grass light, terrain activity debug shader. We have taken the functionality of this one and put it in terrain debug, I think. So we can remove I think we're going to remove terrain activity debug shader and terrain debug shader and just have this. Because eventually, so the naming we're going with here is terrain star shader. So we're going to have terrain ground shader, terrain snow shader, terrain debug shader. So this one is going to be deleted eventually or reworked a bit. We're going to do terrain snow instead. Terrain template, terrain snow, terrain water, terrain ground, terrain grass, something like that. It feels nice to start to clean this up. We're gonna have to go to material as well later on. Procedural grass light, we keep around, snow as well, terrain activity debug shader, delete, terrain debug shader, delete, terrain debug, terrain ground, terrain procedural grass, procedural snow, procedural water, terrain snow, and terrain template. Okay, this is good. Environment shaders. Yeah, let's add the ones that matters here. Shaders, environment. And I want to add terrain debug. I want to add terrain ground. And terrain template. Added. Okay, functional shaders. I don't even know what we changed in this one actually. Yeah, just remove that. So we add that one. Terraform shader, this one we have reworked quite we have just cleaned it up a bit, but this one I want to add. This actually feels great, finally adding all of these changes. Renderer features, we're gonna wait with these. Shader utils, here we have a lot of stuff. The full terrain data is gonna be added. Shader utils, terrain data. Beautiful. Util fog, util helper functions, yes. Util lighting. Terrain marker, both of these actually. Pretty sure that's everything related to the shaders. Let's take a look at these textures here. That one we wait with. Environment textures, displace test, and a lot of terrain height test. We don't need these anymore. No. Okay, so that's good. And let's go through these collections. Maybe tools. Okay, no. Data, weather. We're gonna wait with weather a sec. Input materials is gonna be rough, I think. Materials. What do we have? We have environment materials. Is that only snow and water? I don't know about these. Let's see if we have some leftover materials that are missing shaders currently. The given primitive, yeah. Terrain activity debug, delete. Terrain debug material, terrain ground material, terrain snow material, terrain template material, and terrain tessellation test material. We're gonna wait with those. You definitely don't want to commit this. So it's git materials, environment materials. No water, we wait. Wet, okay. Functional materials, render terrain data material, simple blit, terraform default material. Is this one the one we use? I think so. Terrain activity output material and terrain load material. Let's add these. All of the functional materials, I think. Okay. Functional image effect materials. What do we have? A lot of old stuff here. View normals, vertex, color. Okay. Item light misc. Holy fucking shit, I haven't even noticed that they have... Do they actually show outlines in this preview? That's pretty cool. Misc we're gonna wait with. Prototype materials, we're gonna wait. UI materials. Pointer, yeah, probably gonna add that one. Okay, what more do we have? Models, misc. Yeah. I'm gonna wait with that one. Prefabs, prefabs, prefabs. Environment. This one I worry about, but whatever. Okay. User interface. Yes. Think. Yeah. Holy shit. Yeah, this is a big commit. Resources. Ooh, I want to take, that should be the last of it. Let's see. Resources, terrain data, textures. This one I want to, this should be on the git ignore actually. So this is when we save and load stuff. It ends up here currently. Okay, let's commit this one. And now I want to make sure that we resolve the correct issues. It's related to 36, I would say. And 87. And 100, and we actually resolved that one. So related to 36 and 87, and then I'm actually going to be quite bold here and do resolves 83. Resolves 83. '85. '87. Um, 90. And implement interaction displacement solution. Yeah, it's version 1 at least. 10. So we resolved 5 issues with this one. Yeah, let's do it. Let's see here. So we had 90. 89. Did I screw up? No, I didn't. Resolved. 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 resolved and resolved. Okay, let's take a look at this one then. Implement weather system and snow. Okay, so currently we have environment, environment controller, and then we have weather handler, current weather effect types. Let's take a look at these weather stuff. Can I do this here? Oh, beautiful. Scripts. So we have weather effect type, which is a scriptable object. So we can define weathers like this, which I like. Do we have here currently? We have display name, type name, snow. Okay, I guess that's good. Primary value range. 0 and 1 currently. I don't know. Maybe we can keep it here. And then we have the big one. So materials, terrain materials. That's how we define them. And then we have weather effect, which is an actual instance of a weather, and it takes a weather effect type. It has intensity as well, and I guess the idea is that we're going to calculate intensity based on... we send it in here. I need to double check this. But then when we apply it to terrain, we just do terrain patch set material. Looks okay. Weather handler. Yeah, here we have some... Yeah, we don't have the wind currently with this new system. But we're gonna rework that one as well. In fact, do I want to do that now? Get the grass. I need to figure out how to handle the grass properly before we do this. The idea is that we are gonna have, so wind will be a weather as well. So just like this snow here, we will have a wind data. So the previous solution, we just generate a Perlin noise texture, and that is our wind. That's not really how I want to do it eventually. But we skip this one for now. Instantiate current weather effects. So each day we will generate new weather effects. I don't know how detailed it will be, but based on season, based on previous weather, some randomization. So every new day we call this one, clear the current ones, which we don't really do right now. And I want to take a look at this one. But we create them, and here, okay, intensity, we just send in 0.5 right now. That's okay, and then we do apply to terrain, and that's, we just do a set material. That's how easy it is this time around. The terrain material has its dependencies, so when we set material properties based, so snow depends on activity data and terrain height data, I think. Height and activity height min. So we set those properties in the shader, and then we just set the material like this. Wonder how much more. Some weather effects won't have their own material, but instead set properties in current materials, I guess. Not entirely sure how we will handle this eventually, but yeah. Okay, so that's the full pipeline for this. So now I want to check what happens if we do environment, current weather effect types, and we add snow here. Terrain snow material, terrain snow. Okay, let's see what happens. We get something. In fact, do we actually replace it? Yeah, that might not be what we want to do. Terrain patch, terrain snow material. Snow height. We don't have any errors, but we don't have any snow either. I want to take a look at this material, how it's implemented. Displays down max multiplier. That doesn't seem to work at all currently. Terrain snow. Transform, what do we do here? We do we don't do any transformations, do we? We read this value and then we don't use it. We read this value and then we don't use it. We take, we just set position Y to 1. Okay, that's great. We haven't really implemented this one yet. We're gonna take a look at how we did it previously and just take that implementation and add it here. Although. I really like this, what we have going on here. I like the idea of, so every shader that uses the tessellation solution, it just needs to define its own transform function, or it doesn't have to, but if it want to alter the vertices, it has to. And So we define a transform function, and then we do some stuff in the fragment shader. That's pretty much it. That's pretty nice. Okay, so let's take a look at, we have procedural snow, which is quite heavy, but then again, a big part of this is hull shader, patch constant function, domain shader, geometry shader. Yeah, and then we have snow shader. This one I think is just a copy of terrain procedural snow, which I threw together real quick just for a video, I think. Yeah. The problem with this one is that we're gonna have to recalculate normals, right, for the snow. And we're gonna need some neighboring values for that. And if we take a look at shader utils, util normals, I think it's this one we use the most. But we send in a texture here and a texture sampler. I wonder if we're gonna clean this up a tiny bit or make this more versatile. So in some cases, we would probably like to send in 9 values instead. I reckon. I want to walk the fine line between performance and readability here. Readability in a shader. So in the snow shader, I would like to, we want to calculate like 9 snow vertices, and then we want to get the normals from those snow vertices. We want to get tangent and binormal as well, I reckon. But do we want to store them as, fuck, we are gonna read we're gonna do 18 texture reads. Probably a bit more. So per vertex, we're gonna do around 20 texture reads. It's gonna be texture reads close to one another, so it should be okay. We're gonna do 18 level 0 texture reads and 1 or 2 texture reads from one of the MIP maps. Eventually. Yeah, let's do some experimentation with the snow today. So, I have this idea that if we utilize the activity data, so minimum height or maximum height, then we can use it for so many more things. Because one could think that we would have a separate data texture for snow, maybe. Which might be what we opt for eventually. But like, if we have activity texture and we have min and max height, then we can use it for mud, snow, sand, etc., etc. Okay, so let's do something like this. Snow shader. We don't care about snow shader. We care about terrain snow and terrain procedural snow. Terrain snow and terrain procedural snow. We're going to take most of the logic from terrain procedural snow and put it into terrain snow. It's going to be much cleaner. So let's delete snow shader. Environment snow, environment snow. And let's start by terrain snow. So what we want to do here is um, do we care about height max here? Okay, let's start by doing Oh, do we really? Hmm. This might be a bit overkill. I mean, I guess it's nice to have. Maybe actually. Then we can do some really cool stuff with this, I reckon. But we don't need to do this time around. Or actually, do we? We're gonna do so many texture reads. Mesh dimension. I just want to make sure that we send this in. Mesh dimension, mesh resolution, mesh subquad diagonal, mesh dimension, mesh resolution. Okay, so we need something for this. Let's see. I think we want to wait with this one. What we're going to do is does it exist a use case where we want to set a material on a specific terrain patch but not on all of them? Not that I know of. Okay, let's do this. Get extend. We're gonna do this. So in weather handler, apply to terrain. Not entirely sure I like this flow right here. Maybe. Oh yeah, that's why. Weather effect types, weather handler. Yeah, we're gonna clean this up a bit. Instantiate current weather effects. And then we have it like that. So in set material here, we're gonna set up. So every material we add to the terrain needs to set some properties, and we're talking about mesh dimension, mesh resolution, mesh subquad diagonal. Yes. Material.material. Base mesh resolution. We don't have access to this one right here. So let's see. Base mesh resolution. Could be nice to keep this one around. We have a base mesh here somewhere. Here we have it. But if we're only going to use it for this one, let's see, base mesh resolution plus vector 2 int 1. Is this? Hmm. Aren't we able to send in? It's a little bit weird. Okay. And then we have mesh subquad diagonal. Patch dimension, base mesh resolution. Okay, but something like this. And the idea is that we don't call set material here. Here, which means that we don't need to do this here. We can remove these lines. Yeah, we need to make sure that every material we add actually knows this about the underlying mesh and stuff like that. So now we should have all the proper information sent down to the snow shader or whatever shader we apply. And then I also want to do set material. Mm. Do we want to do this? Yeah, maybe. Yeah, we should be able to get rid of that one by doing a recompilation, I guess. Okay. Thing I wonder, set material. Would like to be able to add back weather effects here. But let's not worry about that right now. Actually, let's keep it, let's do material stacking for now. I wonder if we want to go with if replace Do we just want to do this? To array. Okay. Don't we have add material, set materials? Okay, we get the ground, we get the snow. I don't know about the performance though. Yeah, I'm very uncertain about the material stacking approach. Wonder if we want to do shader passes or something like that eventually. But we're gonna go with this one for now. I don't want to spend too much. I don't want to get sidetracked too much. Let's just add that as a to-do here. Because we're basically gonna have... There's a lot. But let's see here. We have pass count. Find path. Can we disable, enable passes? Pass count, find pass. Returns a name. And then we can enable set pass. Activate the given path for rendering. Set shader pass enable or disable. Is this one just for enabling? Int pass, okay. This might actually be a way better option. Oh, fuck, that would be very cool. I do want to dive into this one, but not today, not today. Set shader pass enabled. You need pass name here, but that's okay. I wonder that this would be pretty amazing, I think. Huh. We'll get to that eventually. Currently we just have our snow underneath here because we don't do anything special with it. Okay, let's see if we can make it look good again. So now we're back to terrain snow and terrain procedural snow again. I want to take the logic we have in terrain procedural snow and I want to add it to terrain snow. But we're going to do it a little bit differently. What I want to do first here is, this is going to be some heavy stuff, but terrain-based data, I reckon, is equal to like this, and then unfortunately we're going to need to do this one. I worry about. Terrain activity data. Let's just go all out and then we try to reduce after if we notice if this is not runnable. Oh, sorry, been muted for a while, but right now this is gonna look rough. So we're gonna read 9 values, and for each value there we're gonna read 9 values. That's insane. Insane amount of texture reads. Probably want to do calculate the normals on texture change and store them. So basically terrain data type. I reckon that's what we want to store here. So height, and then we have normals. Yeah, because we're gonna need this normal quite a lot. But anyway, when we calculate normal data, step UV and step world space is what we want to get. Step world space, step UV. We have this data in here. Do I want to implement a method that is get terrain base data, float to UV, int x offset, int y offset, or is that weird? Help me step UV. I'm stuck. Is that a play on words? I'm trying to get it. Now we're probably gonna do it like this actually. Float to fuck, when I think about it, I'm not entirely sure this is 100% correct. I think we need to do mesh dimension divided by terrain base data size minus 3 here actually. Yeah, that's another thing to double check in the future. I guess it's okay with the normals. It's not that big of a deal when we calculate normals, but so that is step in world space. because we rescale it. Terrain-based data UV step. One divided by full resolution. Yeah, this one is correct, but this one might actually be wrong. Base data size. Yeah, I think it is. Pretty sure. But let's do this. I care if it's bilinear. Um, Something like this. So let's do it like this. This one is correct, that we know. It's this one I'm worried about. Okay. I'm also a little bit wary of the fact that... So basically what we want to do when we do the snow is we want to calculate 9 snow vertices. And each snow vertex is going to depend on both terrain-based data and terrain activity data. The thing is that these might actually be... We might have... different resolutions on the underlying data. So terrain data might actually be 256 times 256 or whatever. Terrain-based data might actually be y times y, while activity texture might be x times x. It's the snow shader we're doing, so it's probably gonna be yeah, we want to base the UV on vertices. What do I want to do this step? Now we just want to calculate one UV for, let's see here, terrain, snow. We want to calculate one UV based on activity data properties, and then we want to send down that UV to base data as well. So we want to calculate a UV here. But it's not actually... Ooh. And then we have tessellation to take into account. We don't care about... Do we care about that? Yeah, maybe we do. Yeah, okay, so, okay, let's do it like this. Get terrain-based data through this one. Terrain-based data UV offset. We're just gonna do this. Is equal to I times Something like that. Maybe it's nicer if we do it like this. And we calculate an offset, and then we do input UV plus offset here. And then we do terrain. Fuck, did I screw up this one? Terrain activity data. This one is the controlling one. Okay, so we just fill this up. It's a little bit overkill. And then I reckon that we're gonna need to do also do we care about positions? Maybe we do. Let's just try this and see what we have. Or see what we get. That's not how we write it here. And it's probably nicer to do it like this, actually. 1, 2, 3. Do we care about positions here? We do. Yeah, we do for the normals. Yeah, that's what sucks. We can call this one snow points. Okay, so just fetch the data. I'm a little bit worried about this one. Get terrain-based data. We probably want to exclude the normals here. Yeah, we definitely want to do it. But then again, depending on the normals, we might want to have more or less snow. I don't know. So here I want to recreate the points, and that's basically going to be, we want to have an offset again, but terrain activity data. So here we want to base this offset on mesh dimension divided by terrain activity data size, which might be wrong then. That's okay. So let's do snow points. Snow points offset in world space. Let's just call it offset world space. But here we see offset. Let's keep this roughly the same. Offset UV, offset world space. One sec. Mesh dimension. Okay. We have offset in world space. Actually, let's take this one and put it down where it belongs. Okay. Snow points I j is equal to float 3 input dot position world space dot x plus, we might as well do it like this here. Yes. And then we have the height as well. Let's just put it to 0 for now. The height. Okay, so here we're gonna put terrain procedural snow. What exactly did we do last time around? Calculate snow vertices. It's basically this we're doing right now. We get the data. This one we have already fetched. Activity height, object space. That's activity height in object space. Not really object space, more like normalized space. Yo, good morning, Cynic. Good morning. And this was a little bit of a shortcut. Displays down multiplier. Yeah, I think we want to calculate this in world space the whole way through. I think. We can try it. See what happens. Include displays down, include displays up. Yeah, I think we're gonna try and make it work without... Or actually... Snow height, very important. We're gonna do snow height in world position, I think. Rain, snow. Let's see here, what do we have? Lighting, yeah, we can wait with this one. Snow height. Yeah, that's good. Base sample level, averaging sample level. Displays down max multiplier. Displays up max multiplier, yes. I wonder if I want to rename these. Down max multiplier. So basically we have from terrain base height data plus snow height, then we know what level the snow is at. And then we have activity min height. That's how far down we should displace it, pretty much. But then I don't want to make, let's see here, I want to rename these. Can I do it with this? F2. I don't know, maybe I can. Yeah, I just want to remove the max here and the max here. Yeah, what's up, wee? Hello from Melbourne, Australia. Damn, that's far from where I'm at. Love how consistent you've been with this stream these couple of years. Crazy. Yeah. Trying to have the mindset of consistency is key, you know. And it has definitely helped me consistently do development on this game. That's for sure. Okay, let's be extremely explicit here. So we're gonna do float. Snow height is equal to terrain base data I j dot height, and this is in world space. Good morning, GDs. Good morning, good morning. Plus snow height. So same old snow. Yeah, we're reworking it with this new system we have in place. We're not gonna need that much time for this, I don't think, but I always say that. So snow height here is the world space snow height, and it's basically just the terrain plus the snow height. But okay, I'm not gonna dwell too much on this, but eventually it would be cool if this is what I've been thinking. So maybe okay, I'm just gonna throw this out here. In the end, we might do a solution like this instead. Base data, or somewhere around here, we might actually add an additional terrain data type that is situational or something like that, where we actually pack snow data into, because it would be fucking great if we could add but okay, that's a level of polish I don't know if we're gonna get in this game. But so we're gonna have static entities, think buildings for instance. We want to get snow on those too as well, but then a plain shader like this won't work. So let's just work with what we have so far. Snow height, and then we want to calculate how much we should bring this snow height down. So we want to get the activity level or activity data. And in activity data, we have minimum height for something that occupies a data point. And in that case, we take so float snow is equal to snow height minus activity data dot height boundary dot x. And clamp. Let's double check the order of this. Value to clamp min max. So I want to clamp this value between so we want to get the distance. We're going to displace this one downwards in world space. Zero, because this one might be way bigger than this one. So if we have negative, we want to get 0. If we have anything positive, this is not entirely true. What happens if we do or actually a better way to do this would probably be I'll just place down multiplier. I mean, we could just do an inverse lerp between ground and ground plus snow height. And then we just do a lerp between those. Is that weird? Is that weird? That should work. Because what I want to do then is skip this one, I reckon. So right now it's quite snow displays down. It's 0 if we're at ground height. It's 1, and then we multiply it with snow displays down. So ground height. I'm wondering if I'm doing this a bit weird. So if we have something like this, plus snow displays down times snow height. We're going to complicate this quite a lot eventually. But we'll see, we'll see. get terrain base data. We definitely want this without the normals as well. I think that's going to be the most costly thing out of all of this. We don't need these normals. We could do some cool snow effects based on underlying ground. We're gonna leave it in, see how it affects the performance. But okay, so here we calculate snow points. And in the end, we're gonna do position world space is gonna be equal to snow points 1 dot just like that. And then we want to get the normal tangent and binormal as well. Yes. View direction. Theme. Fuck, do we use this one anymore? Yeah, we do. Also want to add some, we're gonna add some various offset and stuff here. Yeah, okay. Anyway, we need normal, tangents, and binormal as well, and I want to do something similar to util normals. I want to do something similar to this, but normal data. So we have 0 points, 0, 1 points, 2, 1. Actually, let's keep this one around. So left is 0, up is 2. Right is 2, down is 0. Right is 2 and up is 2. And we have 0, 0. Yo, what's up, Coolers K? Indeed it is. Okay. Left. Upright. So something like that. And then we can use this one here. I wonder if it's... Guess it would be nice code-wise to just keep it here. Is there any drawbacks? I don't think it is. Or is it? What do I actually do here? Up 0. Is this relative? Yes, it is. Zero plus I minus 1 times step ds. Right, And then we have 0 plus... Let's skip those. So vs dot y dot x. So for x up, that should work. And same for this one. Offset UV. Offset UV. The UV in question. And step UV in X, step UV. Oh, have I fucked up here? No, I haven't. 0. Okay, so we pretty much want to do this, but with step UV. Always R here as well. That might be... we're gonna have to take a look at that later on, make it a little bit more generic. We fill it up, and then we do... Hope this is correct. We will soon know this. When it rains snow, then we want to do finally calculate normal. Do we include this one here? I think we get it included from terrain base data currently. Snow points, and then we just do Okay, before I try it, I'm just gonna pour myself a cup of coffee real quick. 1 sec. Okay, let's see what we have. Oopa. Where did I fail? I'm a little bit worried about this though. Float 4 does not have methods, yeah? But... Oh, can't you do it like this here? Okay. Okay, so no compiler errors. Let's see how this looks in game. And that's snow all right. Huh. Interesting. Okay, we get lit there as well. That's good to know. Snow height 0. Hmm. How the hell? Oh, yeah. Try this. We actually have snow-ish at the exact... Ah, yeah. Terrain patch. Yeah. Terrain snow. Let's add some height to it. Didn't really change anything. Ah, that is true. Let's do terrain. I fucked up one calculation. So let's see. Snow height 0.4 and displace down multiplier 1. Calvino, my first peer back from parental leave, is finally up for review. 449 files changed. Damn, son. That's pretty insane. I thought I was doing a big commit this morning, but that's not even close to yours. Okay, we have some displacement here, but it looks like shit. But we can work with this. Don't we have any normals? No, we don't have any normals. We do have shadows. Why don't we have any normals, or is it just that we don't use them? Okay, yeah. Mm-hmm. Yes, okay. So how we handle the extra points, interesting. Hmm. Yeah, what do we do with the center points here? Yes, 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 yes. I'm wondering why it takes some time for it to appear. We had so much nicer snow previously. Makes me wonder. Yo, what's up, Caveman Crafting? Ah, it's moving in the right direction at least. That's always something. Good stuff, I'm just getting up. Gotta finish up work on my crafting bench UI. That sounds pretty fun, actually. I don't care about these shadows. Oh, don't we use the shadows now? Okay. Hmm. I worry about what we're seeing here. That's weird. This. is going on here? Hmm. Okay, I see, I see. Hmm. Something wrong with the normals as well. Hmm. I worry about... Mm. Rough, to say the least. Yeah, we shouldn't get a result like that, I don't think. Definitely not. Hmm. What kind of result do we get if we do? Let's see here. Stage domain, stage geometry. And that's much, much, much better. We need to properly handle those, but we still have some weird stuff going on here. Definitely. Let's make it a little bit easier to see what's going on as well. Terrain, snow, color, lowered color. Do we use these? Color, no. Ooh, that's true. We might want to send something down here. That is true. I didn't think about that. Fuck, I want a variable describing the amount of displacement we do. This one right here is insane. I wonder where that one comes from. Like, how is this even possible? With data like this. We actually have a seam here as well. That's not good. Did I screw up the normal calculations? Yeah, probably. Yeah, we should be seeing way nicer. Yeah, something is wrong in the shader, definitely. Okay, let's just worry about this place down right now. Let's skip normals. But that might be a bit hard to... Hmm. Oh, am I... Oh, yes, 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 yes. What the fuck? UV step. Okay, that's definitely one thing that's wrong. Holy shit. Wow. But I'm still wondering how that could... That would still have been 0, 0 for the center point, right? So it wouldn't really affect the displacement, but definitely the normal calculations. Let's just see what kind of result we have with this compared to what we previously had. Yeah, okay, the normals are way better this time around, but still have some weird displacement going on here. Normals are way better. But every other, I'm wondering if that's the center points. They don't seem to be getting displaced the correct way. Is it purely the center ones though? And we have this one and this one and this one actually. But the normals on these seams are okay right now. That's good. What is this? So we can see here, we don't have a displacement downwards on a lot of those. And if we check this one, Hmm. Doesn't make much sense. Okay, so I missed this one. Offset UV. One, zero. Okay, for the center one, we don't do offset UV, we just do input UV. Snow points. I don't see it. Maybe. Let's take a double look at ground height and height boundary real quick. Not that one. Terrain, base, data. Terrain base data value multiplier. All of them uses the same one here. And we do it here as well. So they should be in the same space. Input UV, input UV, input position V. Ooh. It should be okay. Am I gonna have to read this and output it? Maybe. Let's disable this step once more and take a look at how it looks. Do we still get the weird? We do. This one is what I worry about. Do we have some other resolution on this? What the fuck is... This right here. Is it true to the underlying data? I don't know. Hmm. And they are way brighter, this one and this one. But then we... okay. But then we have this point as well. Is... Oh, have I screwed up? extremely rough. If we do... Mm-hmm. Oh yeah, because we don't have any MIPS on that one. Okay. That might actually be the data we get thanks to this. Hmm. I think I'm gonna have to rethink the displacement. We're a little bit too conservative with it. I reckon. Because if we do... let's keep that one there. We just need to generate some MIPS for it later on, but snow, let's put it back to 0. If we go with the bed, yeah, we might be a bit, yeah. Mm-hmm. Okay, let's do this. Let's try it. Base sample. For activity texture, I would probably like to go with some... Oh, fuck, that's hard. To do. I would probably go with some custom MIP map generation. But for now, let's see what we have here. Rain data type. Oh, we do actually generate MIPs. MIP chain true. Why don't we get any MIPs here? Do we have auto-generate MIPS false? Or we could just call generate additional data, but okay. Do we do this? Draw renderer. Generate secondary data. We actually do, so why don't they generate? Hmm. Or is it because... Actually, it's probably because... Let's see here. Something is wrong with the normal data as well. Um, There we go. Okay, so it's actually... I see. Still, this point right here... This point right here... Okay, something is wrong with those middle points. Because this one should read... Should get it as bilinear here. Okay, yeah. I see. The calculation we do... Okay, so this one does read bilinearly. It pretty much gets a bilinear read from this one. Right, this one doesn't have its own pixel, so it gets a bilinearly interpolated value from this one, and this one. The problem being that this one is 1, so extremely big. So I guess it's 10 actually. And that's why we're not seeing. Okay, so that way of doing it doesn't really work. I get it. Interesting. Yeah, having 1 is... We have 1 as a start value because... we want to do... I wonder if we can do something else. Let me just do a quick to-do, because okay, now we know the reason for this weird, these visual artifacts. But I just want to double check one other thing before we try and fix that one. And that is the normal calculations. Since I added, or since I rewrote this part, I'm seeing some visual glitches I didn't previously. I just want to get to the bottom of those. Let's quit that and let's do environment. Let's remove the snow real quick. Yeah, we don't really have any normals on this. We just have some weird shadows. Nada looks, what up? I'm sure you get asked quite often, but do you intend to post more devlogs, or are you sticking to a live stream format? I definitely wanna post more devlogs. I just need to get going. I've postponed it for quite a while, but they're coming. Yeah, we don't have any normals at all, and what we're seeing here is just shadow artifacts. Extremely ugly shadow artifacts, actually. Mm-hmm. Oh, interesting. Or actually, is it 4? Let's fix the normals here. No, looks sounds good. No pressure, of course. Yeah, it's just that I've been meaning to do some devlogs as well. I've had a hard time finding the time for it though. But I definitely want to do it. Like, I enjoy doing it a lot. Yeah, the shorts have been a nice introduction back to video editing for me. I don't want to make any promises when the next devlog will drop, but I have started working on it recently. Okay, so why don't we get any normals here? That's weird. Did I screw something up here? Yeah, you put a lot of effort in the editing. Yeah, I do. Like, maybe a bit too much, honestly. But I don't want to waste. I don't want to waste the viewer's time. Pretty much, I want to like high effort content is something I respect. How the hell did I manage to screw up this so much? Oh yes, of course, of course, of course. The height is definitely something we want to have here as well. Height, 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 height. We just multiply it with whatever we sample. Yes. I think people appreciate it though. Yeah, I think so as well. And that's what I hope. The animation devlog was, yeah, that might have been a little bit over the top. Okay, now we have normals again, don't we? Yeah, we do. But it looks weird. It's the shadow mostly. Nah, it looks pretty good. Yeah, the shadow looks could be improved, but the normals are correct. I think. Actually, we can do this. Yeah, it looks good, except for the fact that it's point sampled. What the fuck? Okay. Text sampler, I thought we sent down. I thought we sent down terrain. Have I screwed up even more? Or huh? Terrain base data. We send down S as our sampler, so it should be point bilinear. But then again, it might be the debugger that screws it up. Let's... No, get terrain base data. That's... Yeah, I think the normals are okay. Bilinear. Yeah, this we want to fix eventually. It feels a little bit weird. It's probably correct. let's see, let's just make sure. Left minus right, 0, center, right, yes, up minus down, up left, so up left, down right, up left minus right down, and then up or right up, left down. Yeah, that looks all right. Okay, let's leave it. I'm pretty sure it's okay. Pretty sure. Okay, back to the snow. I'm gonna have to rethink. This. Or actually, the biggest culprit, and it was the same with the old system. It's the one in activity data. That activity data height min that hasn't been instantiated is max value, so 1 if we're talking normalized. And that screws up the displacement here. Unfortunately. Or I mean, what it renders is factually true. That point, the point we're trying to displace, nothing that affects the snow. So the minimum height at that point is less. Or the minimum height of that point is greater than the snow height, which means that the snow height shouldn't go down. But it looks like shit, definitely. And that's like one way you could fix it is by going down some MIP map levels, so you pretty much blur the result. And that's when the 1 screws it up. Because if you blur the result, or it's not only the blurring, but when you do bilinear interpolation, one value is 1, everything gets screwed up. Because that one is gonna pull everything up. And so if you have a point, you read that point's minimum height value, but that point is between 4 pixels, so you do bilinear interpolation. If 3 of the pixels are below snow height, but the 4th one is untouched, i.e. has a value of 1, that means that the average of these 4, or the bilinear interpolation between those 4 points, are going to be way above the snow height, even though it really shouldn't. So I guess, or we don't want it to be. You could, like, I mean, a better approach would probably be to render it by flipping the oh fuck, maybe we should do that. Instead of doing blend operation min, instead of doing blend operation min and cull off and all this shit, we just flip the camera so it's underneath. and then we render whatever is closest to camera what. But yeah, that should pretty much do it. But then we have to check against 0. Or if it's 0, we skip it, basically. Averaging it is still gonna... Yeah, it's gonna bring it in the wrong direction as well, but it might be... I mean, we can check against 0, I suppose. Yeah, flipping the camera here, or we're gonna have to do it here. Will definitely improve this. But I don't think it will solve, so it will improve it performance-wise, I reckon. But I'm not sure it will fix the issue. Doing custom MIP mapping would solve it. So we downsample it, but we downsample it in a specific way. I mean, the easiest approach would definitely be to just have a data texture for this specific thing. But then we can't use it for some other cool stuff. But do we care? But one sec. Having it as 0. Still don't, if only this was the problem, we would probably terrain, no. Geometry. That's not what we want to do. We want to add a weather effect. And we want to change this one to 0. Probably as good as it gets with at this resolution. It's still weird, but yeah, that's the problem we're having. Or this one is above snow, above snow, above snow, so we get a line drawn here. What would happen if we go? I want to try this. Let's see if our system supports this then. Terrain data type, base resolution, case, activity, height min, return 56 times. Okay, so different. Terrain height is still 128, so 131, while activity texture is half that resolution. Our snow will still, the mesh here will still be quite big. So we won't really improve. Like, would this... I wonder what happens if we do... Let's just put it all at 256. And this is probably the resolution we went with last time for the snow. Looks much better. But I also want to fix... rain, snow. Let's add back that one, see how it looks. Yeah, it's a whole problem about smoothing it out. And to do that properly, we're gonna need to read some different mipmap levels. And to be able to do that, we either have to generate them ourselves, or I'm quite shocked at how quick it was with double the resolution on everything. That's pretty good. Or we're gonna have to come up with some other solution. What that other solution would be, though, I don't know. What's with the shadows? .256 is so much better. Hmm. We could probably... let's see here. But then again, if you base the... we've gone through all of these solutions. If you base... You want to work with the texture. That should be the base. Because if you do it on... Like these neighbors we get here, they should only be used for normal calculations. Because if we use them for height, that means that we need to get these neighbors if we want to get the normal calculations correct. It's tricky, very tricky. Is it time to implement some custom MIPS for this one? I wonder. Or if we just skip the normals for a second and do... We had... If we just do... We calculate the heights. We calculate all the heights, pixel perfect, and then we average the height. Fuck it, let's just try it. Let's experiment a bit. Yo, what's up, Diligence? Hard at work as always. Wouldn't say it as always, but I try. I do my best. Oh yeah. That's not what I anticipated. Oh yeah. There we go. Yeah, averaging it is fucking beautiful, but the normals, you're gonna have to do something about the normals. Because I'm pretty sure, we still get some weird points like this. Yeah, averaging them is the answer. The problem is, well, the question is rather, where do we want to average them? Do we want to do it in the data, or do we want to do it? Or do we want to do it in the shader in some way? And we definitely don't want to base the tessellation on distance from camera in the Y direction. I would say getting the visuals correct for snow is like how one solves the averaging is probably what affects it the most. So like averaging affects it the most, I would say. Get rid of spikes. Stuff like that. Is this only a normal problem? No. We have... Okay. We can weight it. Oh, there must exist some very smart way to average it without destroying everything. Yo, what's up, Neozoid? I'm trying. I'm wondering. I'm wondering if I have limited myself in a very bad way by trying to keep myself like constrained, or allowing myself to be constrained by these values. Like, did some thinking arrived at these four for some good values to properly affect the environment. But like, I'm wondering if there exists something that is much better than this. Height min, height max. One sec, be right back real quick. Okay, back. Sorry about that. This is not the first time I'm pondering this. Probably not going to be the last. Maybe, just maybe, we're going to leave this as is currently. It would be this one, generate secondary data. if we were to do if we were to just test if this is true, how would we go about averaging the data? So if we downsample it and we average the data, but we ignore once, how would that look? So if we have so if we go from a texture that is 8 times 8, we end up with 4 times 4. So for each point in the final texture, yes, this one will end up as this one. If we see, and we have 1, 0.15, 20. You just pause this one. Or stop it rather. And then we ignore the 1, so 0.15, 0.2, 0.18. So 153. And it becomes smaller, but if we do 0.53 divided by 3, 17. 0.17 for this one. Yeah, that's not good. But if we do 0.15, divided by 4, and multiply by 2 for every 1, here we would get 15, 0.18 divided by 4 times 2 times 2, 33. Doesn't look too bad, maybe. But then again, I'm still worried about the normals. Preferably, we wouldn't do this to the height texture or the activity texture, but purely in the snow shader. In some way. What if we try this then? Terrain snow, so instead of doing the average, we do pretty much do it. Let's see. To get the normals correct, we would probably need to make this even bigger. That sucks. Unless... No points. Number of zeros, 1. non-zero sum. And then we do non-zero sum divided by 9 times how, did I say 2 or do I just want to multiply it? 2 times 2, right? 2 to the power of number of zeros. Snow displays down, snow displays down. Something like that would be the equivalent. The normals are still gonna be way off, but we can get some better understanding of how it would look, I reckon. Okay. Not really, but okay, I get what's wrong here. Averaging is probably, no, averaging is probably not better actually. Pretty bad. But look at this snow. So if we don't take edges into account, but just focus on this snow here, it's probably something like this we want to do. I just need to figure out the correct way of doing it. And then with some nice normals as well. Maybe. This one though, yeah, it's still screwed by the, yeah. Now I've been down this path before, but could one of these save us? Or But. Can we... Can we do something with the normal? If we know the normals, because that is true. The normals, I would like to render them, I think. We can probably displace it based on normals as well. And then we might... Or do we have some extremely weird normals here? Ooh. If we do... I wonder what the normal is for this one right here. Yeah, that definitely looks... Ooh, we can probably do something with the normals. Huh. So the edges... Yeah, what the fuck, I should have caught on this one earlier, I think. Let's see. But can I even paint this? If we have... something like this. Point, 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 point. It's highly unlikely that this one will have a normal that is straight up, since it at least has two neighbors down here. Or, yeah, the neighbors are gonna have to align perfectly. But this one, for instance, this one probably has a normal like this. So, wow, this is pretty... I should have arrived at this one way earlier, I think. I think this is it. We just have to do something very smart with... So if we have a normal that is non... or if we calculate the normals from activity... Yeah, the problem is if we have underlying terrain that looks like this, and then we have snow on top of it, we're gonna get normals like this. So we can't do it based on snow, but we can probably do... fuck, but if we don't do it based on the snow values or the final normal, Then we need to recalculate the normals again, and that's weird. But I still want to... It depends on how... worst case scenario, we have terrain that looks like this, maybe. And then if we have snow like this... And then we have normals here, but maybe we want to make them lower. I still want to try this, but... So if we have normals, if we do dot product between this one, get this value, dot product, and then lower the snow based on this one. I still worry about these cases, but so I guess that would be additional lowering. And if we... So if we have a normal like this, so dot product 0, what if... Of course, the normals are still gonna be pretty off if we... Or are they? If we get the normal... We get the normal direction... If we get the normal direction... We can probably experiment quite a lot here, but if we would do... We get the normal, and then we convert that normal to indice direction. And when we have an indice direction... We try and... So this normal would probably... Thinking if we get the index of this one and then we just interpolate this one so it's halfway, the height of it is halfway between this one and this one. So we bring it down, that's not correct, but bring it down to here. I wonder what would happen with this one. So do a second pass where we correct points, the height of points based on the final normal. And hopefully we don't overcorrect them in such a way that the normals... We're gonna have to do something about the normals either way, that's true. Then when we try to correct this one isn't corrected, so yeah. Okay, well maybe we don't want to take the neighbors into account. Should we allow for... Would it be enough? Hmm. Yeah, what's up, Bobinski? I use ChatGPT to help me write a Visual Studio program that allows control support to my Flash game. That's nice. ChatGPT can help you to join the dark side. Yeah, I use ChatGPT for a lot of stuff. But for stuff like this, it has always let me down, unfortunately. It's layers upon layers of systems and constraints. Yeah, it told me I could send down 4 vertices to my geometry shader, which is not possible. Not with the constraint I had. It's very good, it's very nice, it's helpful, but it doesn't know everything. Not yet, at least. Fuck, normals felt so good. I'm pretty sure this is the key. I just need to figure out how to apply it. That's because you have to send it your entire code too. Nah, that snow mechanic is gonna lag your game to hell. It definitely won't. It definitely won't. Depends on how we implement it. The question then is, Emphasis on depends on how we implement it. There's a fine line between it looking good visually but also being performant. But we should be able to alter the normals if we do a second pass. Thank you, I appreciate the follow. If we do a second pass and we alter the point, if we alter the point is in a very, depending on how we alter it, we can probably align the normal to normal so the normal still works. But I wonder what happens, what kind of chain reaction do we have here? So this one we don't change, but maybe that's okay. Okay, so we calculate normal, we take the dot product and do something smart. Maybe it's enough to, when we move it down, we move it towards this one. I want to experiment with some rough stuff. See what happens. So we have normal data here. What happens if we... Okay, let's do... Oh, vector 3. Float 3, 0, 1, 0. And then we do... UV offset, did we calculate this one somewhere? Step world space, beautiful. Max of step world space, X step world space, Y, And we multiply this one with normal data dot normal. Does this make any sense? So we take the final snow point position. Now we allow for movement both in X, Z, and Y. Because I want to keep the I'm hoping this will somewhat keep the normal correct. If it's no, okay. Dot gives 1 for this, right? And 0 for this, and -1 if they are totally opposite. So we want to do can we do 1 minus? So we have a 1, so then we have 0. Here we have 0, so we have 1. And here we have -1, so we have maybe. Yeah, let's try this one. Very interested in how this will look. Dot. Oh, yeah. Let's just call it A. Do we get... Yeah, okay, we might not... Ooh! But actually... Okay, X, moving in X and Z is a bad idea. But... moving in X and Z is definitely a bad idea. Okay. But if we just move in... Okay, if we limit this one to the Y axis, although I wonder why it didn't work by changing X and Z as well. That's weird. What I want to do here. Actually, let's test it. Let's just see how this affects it with some different values. This will probably not be enough, but we'll see. Hmm. Probably don't want to move. If it's already too low, we don't want to go even lower. This one is weird as hell. This one right here. Yeah, and then we have points like this, which unfortunately screws it up a bit. But now when I think about it, we could probably rely on the MIP maps if we just set up a set of rules beforehand. So for instance, like, okay, so if we take the MIP into account, roughly it should be 128.64, so 4 pixels become 1 pixel. If our snow height is like, what I'm getting at is we can probably calculate how many points that are below snow and how many are above snow. So if we have one, okay, let's say that 0.2 is our snow height. 0, 0, 0 results in 0.25. We're gonna have to read the height value as well. But let's say that we work with distance from ground instead. So this is, and then we have 0.2, 0.2, 0.2. What do we have? 1.6 divided by 4, 0.4. Hmm. Like if our mean value is somewhere between these. Yeah, but we could have other values as well. Yeah, this one could be 0.4, this one 0 and 0. Might be a bit too simplified. Like I'm trying, if we can deduce from the value in the MIPS how many ones we have. I don't think we can do that. You know what? I need to run, but we're back on track. We're exactly where we were previously with the snow, but now with much better data behind. If I don't come up with some extremely smart idea that I just have to test tomorrow, we're probably going to do some other stuff tomorrow. So we're going to leave the snow as is currently. I want to do some chill stuff for a while now. Some easy game logic maybe. We'll see. But yeah, we're going to end it there. I'm pretty sure we're going to have to generate our own, either change the data we store or generate our own MIPS, useful MIPS. But yeah, we'll see. Thank you so much for watching, everybody. Appreciate it. And have a great rest of the day. Peace.